Welcome my dear learners for this course on engineering graphics. In this module 2 we are discussing on orthographic projection of plane surfaces. So far we have solved 8 problems on orthographic projection of plane surfaces. Moving ahead, the problem number 9 of our discussion states that a square plate of 30 mm sides rests on HP such that one of the diagonals is inclined at 30 degree to HP and 45 degree to VP. Draw its projection. We have a square plate of negligible thickness of sides 30 mm. It is resting on HP. So in the first position I should place the laminae on HP without inclining to any of the planes. So if I place it on HP, in the top view I can see the square of dimension 30 cross 30. One important point to be observed is we should draw the square such a way that we should get diagonal. I can get diagonal if and only if I draw a square in the view of an rhombus such a way that I will get corner on either side. If I draw square such a way that I will get edge on either side, I won't get diagonal in the projection. Let me solve and explain properly. So first let us lay down xy line. Let us lay down xy line for the problem number 9. So I have drawn xy line. Now if I draw square such a way that if I take edge on either side, the projection will give us 30 mm side. So I am unable to show the inclination of diagonal further. The only possibility is if I take corner on either side, the projection will give us the diagonal. Then I can show the inclination of the diagonal in the second and third step. So therefore, for this problem, since he states we should incline diagonal, the only possibility is that we should draw square such a way that I will get diagonal on either side. So this I have already explained. So first you draw an horizontal line which is nothing but a diagonal line for us. So from one of the corner you measure 45 degrees, measured, and now you take the given dimension, that is 30 mm side length. So measure 30 mm. I have drawn 30 mm. So this angle is 45. I have taken a reference and measured 30 mm. Now we extend this further and also drop a vertical line from here, a construction line from here, that is from the end of 30 mm line, drop a vertical like this. Now using compass you intersect vertical and horizontal line to complete the square. So measure 30 mm. So keeping from one end I will intersect this horizontal, keeping at the intersection I will intersect this vertical line. So now if I connect, I will get perfect square of 30 mm side with corner on either side, whose projection will yield us diagonal. This is how you should construct. So now dark the laminae, that is we have a square laminae. Now mark it as A, B, C and D. Now in the front view observer will be here. So for the observer A, B, C is visible and D is invisible. Now take the projection and construct the front view. So front view is nothing but the diagonal AC. So I have taken the projection. If I complete the drawing, the front view will yield us, this is A dash, B dash is visible and D dash is invisible, and this is C dash. So now we can see we have got diagonal in the front view. So if I draw square such a way that I will get edge on either side, the projection will give us side. So therefore you should draw like this to get diagonal in the front view. This is vertical plane, this is horizontal plane, we have x and y. Now since the lamina is resting on HP, the second position should show inclination with respect to HP itself. The inclination with respect to HP will be shown on vertical plane. So how much is it inclined to HP? It is inclined at an angle of 30 degrees to HP. Now Let us mark A dash. Let us take this as A dash and measure 30 degrees. Measure 30 degrees. Measure 30 degrees. Now you transfer the diagonal. So measure the diagonal. I am getting 90 mm as the diagonal. So transfer the diagonal here. That is 90 means 45. I am getting 45 mm as the diagonal. So transfer this 45 mm here. So transfer the diagonal which is measuring 45 mm for me at an angle of 30 degrees to HP. Transferred. Exactly at the center we have B dash D dash. Exactly at the center we have B dash D dash. This is B dash D dash and we have C dash. This angle is nothing but 30 degrees given. Done. Now take the projection vertically and horizontally and complete the drawing. So take the projection, vertical and horizontal projections, and horizontal projections, and we have D dash till here. So if I mark, I'll get this is D dash. D dash and D is D. Here we have A. This is not required. And here we'll have B. And here it is C. So now you connect. Connecting. Done. So I complete the drawing. A, B, C, D is the lamina. Now the careful observation reveals that initially the diagonal length is 45 mm. Now if I measure the diagonal, it is reduced. It is measuring only 40 mm for me. Initial diagonal length is 45, whereas now the diagonal length is reduced to 40. What he has given, the inclination is for original diagonal. Original diagonal is 45 mm. 45 mm should be inclined at 45 degree to VP, but what I have now is only 40 mm. So therefore I should go for beta angle. You know how to construct the beta angle. Let me construct once again and explain the construction procedure for beta angle. Why we are going for beta angle? This is because of the reason the dimension which we are going to incline has been reduced. That is, I am going to incline the diagonal. The diagonal is not retaining its original dimension throughout the drawing. So since we have apparent diagonal here, I want to know the apparent inclination. Now in order to find the apparent inclination, first you draw a line for the true inclination. The true inclination is specified as 45 degrees. First you draw a line for 45 degrees. Let me draw a line for 45 degrees. So if I measure 45, let me draw 45 degree line. I draw a line for 45 degrees. Now on this line you insert the true diagonal first. Let me fix C. Let me fix C. Let me have C here. Now the true diagonal is known. True diagonal length is known to me, which is 45 mm. So mark 45 mm at an angle of 45 degree. At the end I will get a new locus of A. So fix new locus of A. So C to A is original diagonal inclined at original angle of 45 degrees. Now you measure apparent diagonal CA. Measure apparent diagonal CA. So keeping at C, intersect this new locus. Intersect this new locus like this. Now for this apparent length, I will get apparent angle, which is beta. Extend it back and measure the angle passing through C, intersect XY line. So this is the required AC diagonal, and beta angle if I measure beta angle is found to be 55 degrees. So beta angle is found to be 55 degrees. Here we have beta, which is equal to 55 degrees, whereas true inclination is given as 45 degrees. Hope it is clear. Now on the true AC beta angle, construct this D and B. So to do that, let me use compass. From A you measure D, cut an arc. So from C, D is measuring same length, you intersect this previously drawn arc. Similarly, from A you measure B, draw an arc. From C you intersect this previously drawn arc. Now joining this, we will get the final position, top view. This is required D, A, B and C. Now take projection and complete the sketch. So D is still here. It is resting on A dash. Then we have C dash till top. Take the projection, and then we have D dash till here. Now take the horizontal projection, C dash, B dash and D dash, B dash and D dash. So we have A dash, B dash, C dash and D dash. Now draw it. A dash, B dash, C dash and D dash. So A dash, B dash, C dash, D dash is the required final front view for the given problem. Here we have Y. So this is a beta angle problem because the dimension of the diagonal is not constant throughout the problem. It is varying from position to position. So therefore this is a beta angle problem. Now moving ahead for problem number 10, which states that the top view of a square lamina of side 30 mm is a rectangle of side 30 mm cross 20 mm with the longer side of the rectangle being parallel to both HP and VP. Draw the top and front view of the square lamina. What is the inclination of the surface of the lamina with HP and VP is the question. The top view of a square lamina of side 30 mm is a rectangle of side 30 mm cross 20 mm. So what we have initially is a square lamina. Its top view looks like a rectangle of 30 cross 20 when it is inclined to certain angle with respect to horizontal plane. Now let us solve this problem. The top view of a square lamina is 30 mm. So it is resting on HP. Therefore the top view of the lamina is a square of 30 mm. When it is inclined at certain angle to horizontal plane and viewed from the top, it is looking like a rectangle of 30 cross 20. Come, let us solve the problem. First let us construct square lamina of side 30 mm. Let me construct a square lamina of side 30 mm first. Let us have XY line. What we have initially is a square lamina of side 30 mm. Let us take it as X vertical plane and horizontal plane. Initially we have a square of 30 mm cross 30 mm square. So construct a square first. Let me construct a square like this. Construct a square of 30 mm. Done. I constructed a square and let me mark it as A, B, C and D. Now observer will be here. For the observer, A and B is visible, D and C are invisible. Now if I take the projection, we'll have the laminae like this, whereas A dash is visible, D dash is invisible, B dash is visible, C dash is invisible. Now this laminae should be inclined to HP such a way that in the top view it should look like a rectangle of side 30 cross 20. I don't know at what angle it looks like a rectangle of 30 cross 20, but one thing I know, the top view is a rectangle of 30 cross 20. So therefore what I will do is that first I will construct a rectangle of 30 cross 20. Let me take the projection and construct a rectangle of 30 cross 20 like this. First let us construct a rectangle of 30 cross 20. Done. So this dimension is 30, whereas this dimension is also 30, because initial position it is a square. Now we have a rectangle of 30 cross 20. Now this has become 20, this is 30 itself. Right here we have D, A, B and C. Now you take the projection. Now extend this side further upwards like this and measure the front view, which is 30 mm, using which you cut an arc. Now extend it back. So if I join, I will get the inclination. So this is the front view of the laminae. This is A dash, D dash, here I have B dash, C dash. Now I can measure and find out what is the inclination to make this square laminae look like a rectangle of 30 cross 20. How much is the inclination? The inclination is found to be 48 degrees. The inclination is found to be 48 degrees. Now what he asks is done. It is look like a rectangle of 30 cross 20 with the longer side of the rectangle being parallel to both HP and VP. I should make the longer side parallel to both HP and VP, which means that this is the longer side, make it parallel. That is, I should take it and rotate. Dimension is known, 30 cross 20, just you draw directly 30 cross 20. That is, this is 30 cross 20. Done. So I made it parallel, longer side, that is, I will take it as CB, A, B, C and D. So longer sides are parallel to both HP and VP. Now we take the projection and complete the drawing. So if I take projection, B and C is at the top, so take B and C at the top. Take the projection like this. I have taken the projection. So done with the required front view. So this was the required solution for the problem. We have got D dash, A dash, B dash and C dash. You can observe longer sides are parallel to both HP and VP. Further he is asking what is the inclination of the laminae with HP and VP. It is inclined at an angle of 48 degrees to HP and 42 degrees to VP, which is also seen if I draw the side view of which. So therefore let me construct the side view. Since it is a first angle projection, right side view will always gives us, right profile plane. Right profile plane will always gives us left side view, correct? So for first angle projection, right profile plane, let me construct a right profile plane, that is RPP. So I am constructing right profile plane RPP, which always gives us left side view. This you people already know. Now we know how to construct the side view. First you draw 45 degree line. Construct 45 degree line. I am constructing 45 degree line. Then take projections and intersect this 45 degree line. Done. Taken the projection and intersected. So from here also this is C and B and this is D and A. So here you have D and A. So this will be D double dash and A double dash, D double dash, A double dash. So similarly here we will get C double dash and B double dash, C double dash and B double dash. Now if I join these two, I will get the inclination. The inclination is found to be, you can see here, it is inclined at an angle of 48 degrees, which is already seen. With vertical, if I measure, obviously it will be 42 degrees. Correct? So this is the solution for problem number 10. So always remember, we should show the dimension at least once. I shown the dimensions. Here also you better show the dimension. That is, the dimension is given. It is a square of side 30 mm. Unless otherwise specified, all dimensions are in millimeters. So this is 30. Angle is 30 degrees. Here true inclination is 45. Since diagonal is not retaining its original dimension, we have went for beta angle. Beta angle is found to be 55 degrees for this problem. So this is the solution for problem number 9 and 10. That's all from this lecture. Thank you all.